Hello everyone, welcome you all to the lecture series on heat and mass transfer. In the first lecture of heat and mass transfer series, we are going to see what is thermodynamics. That is the review of thermodynamics. Previously, you may study about the thermodynamics, but to start the subject of heat and mass transfer, you have to know the fundamentals of the thermodynamics. So, I am taking the basic definitions and fundamentals of thermodynamics as a first class of heat and mass transfer lecture. Okay. So thermodynamics. What is meant by thermodynamics? Basically, thermodynamics is the study between the heat, work, temperature and energy. That is the relations between the heat, work, energy and temperature. Initially, in the subject of thermodynamics, you may study about heat and work relations, how the heat is converted into work, how the work is converted into heat. What is the possibility of converting the heat completely into the work, similarly in vice versa. So then what is temperature? You may know that the temperature is the indication of heat, how much heat energy is there. That is, the indication of heat is called as the temperature. In other words, it can be called as the total kinetic energy of a system is directly proportional to the heat energy and which is directly proportional to the temperature. That is why we are taking the temperature as a measure of heat. Then energy conversions, maybe kinetic energy into some other energies, mechanical energy into some other energies. Those energy conversions part of yours you may studied in the subject of thermodynamics. Then we move to the laws of thermodynamics. There are basically four laws, four basic laws of thermodynamics which forms even the nature. That is zeroth law, first law, second law and third law. The zeroth law deals with the equilibrium conditions. That is, you may know that the one body A is in equilibrium with body B and body C, then body B and body C are in equilibrium to each other, which is a perfect example of thermometer, right? In the first law, you will see about the first law is actually derived from the conservation of energy. So first law deals with the conservation of energy. When you consider the conservation of energy, you will know curiosity about the availability of the energy. Some energy will be disappeared during a process. That disappeared energy is called entropy. That is the second law. The second law deals with the completely with the entropy. The two statements deals with the entropy. The concept of entropy arises in the second law of thermodynamics. And the youngest law, last law is third law of thermodynamics. If you take a pure crystalline, this law is very very important law. If you take a pure crystalline and if you reduce the temperature of the crystalline at a particular temperature, the entropy of the crystalline will become zero. That particular temperature is taken as absolute zero temperature, that is 0 Kelvin. So the third law defines the Kelvin scale temperature, that is 0 Kelvin. Okay, from the 0 Kelvin only we are doing all the calculations in thermodynamics and heat and mass transfer. So the third law of thermodynamics defines the absolute zero or 0 Kelvin and Kelvin scale. Okay, then come to the very basic definitions. In the very first thing you will study about system, boundary and surroundings. So what is a system? System is a finite quantity of matter or a prescribed region or a particular region in the space. If you take a system or if you take a jar to the thermodynamic study, then the jar is called as the system, right? That is what given here. The boundary is the actual or hypothetical envelope closing the system. The boundary may be movable one, fixed one, imaginary one or a real one. So the boundary may be fixed in the condition when you consider the jar as a system. The boundary may be moved when you are considering a piston cylinder arrangement as a system. The boundary may be imaginary when you are taking a particular space or a particular region in a room, or it may be real when you consider the room as a system, right? all other things except the system is called surrounding. Okay. Then, what is mean by work? The definition says that work is said to be done when a force moves through a distance. For example, you take an object, if you are going to move an object in x direction for a distance of y, what you will do, you will give a force in the direction of x until the system or that solid reaches the distance y. So the work done is the force into distance, that is maybe taken as pressure into area where the boundary is movable, that is given in the second part. When you are giving the force to a solid object, the object will move. When you are giving the force to a boundary which can create the pressure inside the system, then the boundary under the action of force move will move, that is the system volume changes. In that case, the work is taken as pressure into area. Okay. Then heat is a form of energy which appears at the boundary when a system changes its state due to a difference in temperature between the system and surroundings. That is, because of the temperature difference between the system and the surrounding, the system's state will be changed. That form of energy is called heat. Then you know about the homogeneous system, heterogeneous system. So basically, if you consider a system, the system consists of two or three matters within that system, and those two or three matters are in a single phase, in the same phase. Then the system is called homogeneous system. If the system contains three matters which are in different phases, then the system is called a heterogeneous system. I given the example for homogeneous system and the heterogeneous system here. We can look at that. Then the thermodynamic equilibrium. Thermodynamic equilibrium. A system is in thermodynamic equilibrium if the temperature and the pressure at all points are same. For attaining thermodynamic equilibrium, the the denoted three types of equilibrium states must be achieved. Those three equilibriums are thermal equilibrium, mechanical equilibrium, and chemical equilibrium. When the temperature of a system does not change with the time, then the system is said to be under thermal equilibrium. If you consider this mechanical equilibrium, if there are no unbalanced forces within the system or between the system and the surroundings, the pressure of the system does not changes with the time, then the system is said to be under mechanical equilibrium. Consider chemical equilibrium. If there are no chemical reactions takes place in the system and the chemical compositions which is same throughout the system, then the system is under chemical equilibrium. A system can be under thermodynamic equilibrium when these three equilibriums are maybe two, at least two equilibriums are present in the system. Then in the thermodynamics you may study about all these definitions like state, what is process, what is cycle, what is paths, or if point has been ordered unnecessarily, point function, when the system has to be considered as closed system, when the system has to be considered as open system. All these things you may study in the thermodynamics, but these things are all not that important in the heat and mass transfer. But the things which we are discussed earlier are going to be plays a crucial role or certain role in the study of heat transfer. Okay. The next class will be the introduction to the heat and mass transfer. Why we are studying heat transfer and when heat transfer study has to be done. Why we are studying heat and mass transfer simultaneously and what are the purposes of heat transfer, importance of heat transfer. All those things we will discuss in the next class. Thank you all.